All right, so we ended last class. We learned about how to do ice tables for a weak acid. Do we need to do ice tables for a strong acid? Why not? They dissociate fully. Therefore, if you know the molarity of a strong acid, you know the molarity of the H plus that's produced, and you can take the negative log of that. Today's quiz will be the last 10 minutes of class. Somebody set an alarm for 11:40, please. And then you will have the last 10 minutes plus an extra 25 minutes to get that in on Canvas. You will be allowed to talk to each other and things like that. So make sure you look and see who got high scores. Who got 95 or higher? Raise your hand. Just kidding. You don't have to do that. But if you did, help people, okay? Spread your love. Don't be hateful, okay? Are we going to impose tariffs on the class for, I don't even know what a tariff is, but I heard the word a lot, okay? So when we take the quiz, spread your knowledge, okay? On the quiz, there will be a strong acid for number 1. So you just find the pH. There'll be a weak acid for number 2. That will be evidenced by actually, there's more space for number 3. Number 3 is a strong base. A strong base is just like a strong acid. The only difference is if it is a base that has like 2 hydroxides, you would double the concentration. Okay, so we will look at that stuff again more today. So doing the weak acids, that's going to be on the quiz. So it would be something like this where you either use the approximation or you don't. I'm pretty sure you can use the approximation for the problem in the quiz today. We'll be looking at finding the pH of a weak base today also, which is basically the same thing. It's just having a slightly different equilibrium concept. If we learn how to do the concepts, you could apply it to anything. You don't need to like be in a box and just, oh, I only know how to find a strong acid. I don't know how to find a weak acid. I don't know how to find a weak base. So make sure you learn the material instead of memorize. Now, another thing that we can think about is how much an acid ionizes, okay? So with strong acids, we get 100% dissociation, right? That means that whatever the molarity is of the acid, that's the molarity of the H plus. So we're only really going to look at percent ionization for weak acids, right? So what the percent ionization is the concentration of the H plus. And remember, H3O plus and H plus are interchangeable. The concentration of H plus at equilibrium, so after you have calculated the equilibrium concentrations, and we have to use the Ka values, which is just the equilibrium value of that specific acid, over the initial concentration of the unionized acid. So if an acid, so when I was talking about this classroom, if we have a lot of people here today. Maybe we knew there was a quiz or something weird, huh? I should just give a quiz every day. Would that boost up enrollment? Oh, on the quiz, number 4, you know how I say, like I give you free points? I'm going to write a word on the board. So those of us who are here can write that word to get the 2 points. And the ones who aren't here, you can tell them if you want. So if you're missing class and someone tells you, that's called having friends, okay? I know that's unfair, but you don't have to have friends. You can just have acquaintances. In life, if you miss class and you want to find out what's happening, you can come talk to me. Oh my gosh, that's talking to a teacher. Maybe you're uncomfortable. Go talk to someone else in the class. So in life, you have to be able to talk to people, know people, and things like that. Of all the jobs that I've gotten teaching, I would say 75% were just because I knew someone at the job. And because I kill it, but other than just kidding. But honestly, like I only went through I've taught at over 10 schools and I've only gone through like 2 real interviews where I had to like interview raw. Some of it was just sending emails to people and saying, is there any openings and things like that? So you have to be able to reach out to people. That's an important skill to have. So if you miss something, come talk to me. Worst thing I'm going to do is say no, and you're exactly the same as if you didn't ask me. The best thing is I can be like, okay, you can make this up, and I will not, take away points for you missing class and things like that. So you have to learn to ask for things in life, okay? No one's just going to offer you things because you're a pretty face and things like that. Maybe it will happen that way. But in general, you have to be social. Getting jobs, in this world, a lot of people are going to be equal on a lot of accounts. What's going to be the thing that differentiates you? Being able to talk to people, being able to socialize. So if you miss class, find someone in this class who you can contact. I don't know how people contact each other anymore because I don't have any of those cool systems of DMing or anything like that. I don't know what any of that stuff means, but you should know how to do that, okay? So when we take the quiz, don't be afraid to go talk to someone. You're like, oh, I'm not a social person. That's on you, okay? This is a class where it's easier if you talk to people and you work on the material together, okay? So if you're more likely to work together with someone than to work on the material on your own. So those are some words of advice in general. Talk to your teachers, talk to your employers, talk to people in the class, get to know people, and then when you miss stuff, you can figure out what you missed and things like that, okay? So that's for the quiz today. Going back to this stuff, and the reason why we got to that is so if we had 100 people and we all were wearing hats and we were weak acids, right? Not every single one of us would take off our hats to dissociate. So if we had 100 people and 10 of us removed our hats, then we would have 10 hats that are just by themselves, which would be the H pluses that are dissociated so we would have 10 H pluses over the 100 original. 10 divided by 100 would give us 0.1 times 100% would tell us that 10% of the acids in this room dissociated. Does that make sense? So basically, you're just going to look at, so this is also the same thing we do when we check for the 5% rule, right? We see what X is and we divide it by the original concentration. So it's pretty much exactly the same. And that's how we're going to be calculating this stuff. So let's go ahead and do a problem. So in general, some things about dissociation. According to Le Chatelier's principle, if we reduce the concentration of all aqueous components, the equilibrium should shift to the right to increase the total number of dissolved particles, since there's more on the right. So what we're going to see is the percent ionization for any acid is not constant for a weak acid. You might think that if it has this Ka, the percent ionization will always be the same ratio. It is not the case. Depending on if it's more or less concentrated, it's going to change it a little bit. So the result will be a larger H3O plus in dilute solution compared to the initial concentration. So if we have a weak acid with the equilibrium concentration of a weak acid increases with increasing initial concentration of the acid, therefore the percent ionization of a weak acid decreases with increasing concentration of the acid. So let's go ahead and look at a problem like this, okay? So let's find the percent ionization of a 2.5 molar HNO2 solution. So for this problem, if we were if this was on the quiz and I said find the pH of this acid, you would still do this thing. So don't think oh, this isn't going to help me on the quiz. This will for sure help us on the quiz, okay? So if we have a 2.5 molar weak acid solution, we're going to generate our ice table, right? Ice tables are going to be something we need to generate. Those of us, so everybody saw that I put an initial score on the exam, and for the most part, everybody's score went up. Did some people's score increase significantly? Yes? No? I mean, I saw someone doubled their score from partial credit. It means they probably had a pretty low initial score, right? But in general, the people who had really big jumps in scores was because they show a lot of work, okay? So I don't know how many times I have to tell you this, but showing work is of the utmost importance for this class, okay? So for the final exam, so I will allow corrections for this second exam. The third exam is going to be a take-home exam Because of that, I'm not going to give corrections because you have the amount, like I give corrections on a 50-minute test because maybe you didn't have enough time to get everything done. And I want you to understand it. On this third exam, I want you to work on it, and I'm not going to offer corrections on the third exam. On the final exam, I'm not going to email you your exam and be like, oh, do you want to correct this? So pretty much corrections are not going to be a thing. So you're going to want to show your work on all the exams from here on out. Okay. Some of you might notice like, oh, I didn't even write anything on this other than like a couple. I rewrote the question and I still got a couple points. To me, rewriting the question is a good start. If you do nothing, you will never get anything. It's just like asking for something from a teacher. If you never ask, you'll never get anything. If you ask, maybe you'll get, a boost in your score. Maybe they say no. So when you rewrite the question, maybe it doesn't help you, but maybe rewriting the question, you're like, oh, I remember writing a concentration and then I did an ice table. Maybe I should do an ice table on this. And then you're on your roll and you're doing good things, right? So that's why I'm telling you, practice the material, muscle memory. The more you do these things, the better off you'll be. So for this problem, write this stuff down while you're doing it, okay? So you make an ice table, nitrous acid dissociates into H plus and NO2 minus. We have an initial concentration of 2.5, and we start off with zeros for each of these. What was the reason for the almost zero here? Anybody remind me? Robert, why does it say about zero and not zero? And what's that little bit from? Yeah? Huh? Autoionization of water, right? Water always has a little bit of H plus and OH minus, and therefore, but compared to 2.5 molar nitrous, or compared to how much it's going to make, it's going to be a super small amount. So we're going to say about zero. Okay. Now we know we're going to subtract from this side. We have to add to the sides with zero. Therefore, we get 2.5 minus x and x as our equilibrium concentrations. When we write our equilibrium expression, which is just review from chapter 14, we're going to put in an x times an x, which equals x squared. That's where that x squared is coming from. 2.5 minus x comes from the equilibrium concentration of this weak acid. Now we look up the Ka value, which is 4.6 times 10 to the negative 4. It is not the smallest number when it comes to weak acids, but because we have a pretty large initial concentration of 2.5 molar, that 0.0004 value tells us, well, I would always try and do the assumption, okay? And just to be honest, like it'll make your life easier and then you can check the work. In this case, let's do this problem, okay? So we make the assumption that x is small, so we cross it out. We get our Ka equals x squared over the initial concentration. So one time I was working with a lab teacher and they told me that you can always just take the Ka times the initial concentration and take the square root of it, okay? That's like a shortcut that I don't teach because shortcuts don't seem good for me. Yes, Emily. Yeah. You're gonna have to put that. So, like, let's say it made like 2 of these randomly, right? If it did that, then you would have to put plus 2x over here. And then it would be x times 2x would end up being like 2x squared. And don't worry, Emily, that's coming real soon when we get to KSPs and stuff like that. So we will see. So right now we're doing this at like a kind of minimal level. We will go on and learn about things that have like different stoichiometry. So like things that have like multiple, so would it be like plus 2x or plus 3x? So that's a good question. But right now, for most of these weak acids, we're only going to focus on one of each. So this is the important thing for learning how to do this. We solve for x, so you need to know how to solve for x, and we get 0.034. So how do we check to see if this assumption was valid? Anybody remember? How do we check if the assumption is valid, honey? What do? We take x 0.034, and we divide it by the initial concentration of 2.5, and we times that by 100%, and we get, let me do this in my head, 1.4%. Think I did that in my head? Just kidding. The only reason I know that is because it's the same for percent ionization. So if this acid ionized to have 0.034 moles of H plus at equilibrium, and the initial concentration was 2.5, notice how the percent ionization is basically the same as the 5% check rule. Okay? So by the 5% check rule, was this assumption valid, Ian? What do you think? Yes or no? Is it less than 5%? Yes, 1.4%. That tells us that this assumption is valid. It also, since the question asks us, find the percent ionization of this, it is just the amount that it dissociates over the initial concentration. So this acid has a 1.4% dissociation. Any questions on that? So I think there's a couple questions on this. This is the same thing as finding so if I was trying to find the pH of this acid, which would be something we have to do on the exam, what would we have to do for this? Jackson? At what point? So we go back to the results of our table. We see what the H3O plus concentration, so that's equal to X. So we have the H plus concentration is 0.034. So how would we calculate the pH? pH equals negative log of H plus concentration at equilibrium, which is what that is down here. So anybody do negative log of 0.034? What do we get for this? Around 1.5. Should this weak acid have a pH of 1.5, Sydney? Does that make sense for a weak acid that has a semi-high concentration to have a pH of 1.5? Is that acidic? Yes, it is. So we feel confident. So you don't have to know that it should be like in the 1s or in the 2s or in the 3s. You should just know that you should get a value less than 7. So if you like did a problem and you get a value that is like, so for instance, let's say on the quiz today, I asked you to find the pH of a basic solution, and you use the method where you find the pOH, and you get a pOH of like 1.5, right? So if you put the pH as 1.5, you should be like, wait a minute, this is a base that has a pH of 1.5. You'd be like, oh, I saw for the pOH, I need to do 14 minus the pOH to get the pH, which would give us a basic pH, okay? So you don't have to like really know what the answer should be. You just have to know what realm that answer should be, right? So when you put an answer, I want to know, like, should it be acidic or should it be basic and things like that, okay? So any questions on percent ionization? It's basically, so this is once again doing the ice table for a weak acid again. And once again, don't worry, we are going to be doing some mixed acids where we'll still continue to do this stuff. So, but does everyone understand percent ionization? Any questions before we move on? Great. Okay, so which weak acid solution has the greatest percent ionization? Which solution has the lowest, most acidic pH? Ooh, that's a hard one. So any thoughts on this? Do we think that, so they're all the same acid, right? Do we think that the one with the highest concentration or the lowest? So which one should we eliminate right off the get-go? Nate, which one can we eliminate? And why is that? That's correct. No, it doesn't. Well, good guess. And if it was a multiple choice on the test, you would have got it right. Jessica, why can we eliminate A for this one? Everybody hear that? When you have a multiple choice thing and it's something that's an extreme, it's usually not going to be the middle thing of an extreme. So if we were not sure, we would just eliminate A and guess B or C. What are you going to guess, Ricardo? I would answer if that was right or wrong, but I actually don't know. So let's see what it is. Solution C has the greatest percent ionization because percent ionization increases with decreasing weak acid concentration. So basically what this tells us is the lower the concentration, the more the thing will ionize. And this has to do with Le Chatelier's principle, but I really don't want to like think about it because sometimes I confuse myself when I do that. So really I just want you to know that if it's so when all acids, it's all acetic acid, the lower the concentration of that acid, and these are the concentrations 0.1, 0.5, and 0.01, the lower the concentration, the greater it dissociates, which also means the higher the concentration, the less it dissociates. And this would be based on Le Chatelier's principle. And like I said, you don't need to, I mean, you could think about it. This is the kind of things that you talk about with other students when you're studying, okay? Solution B would have the lowest pH because it has the highest H plus content. So even though it dissociates less, it's still going to give more H plus, right? Even though if you have less percentage of a lot more stuff, it's always going to be more. Question, Jessica? Theoretically, that could be right, but it's actually changing the percent. I mean, like if it was the same, if it's the same ratio every time, the lower denominator would make a same amount of lower numerator, and it would always be constant. So it's not a constant percentage. As the concentration goes down, it actually separates more. So it would be like this: if we have 100 people in here, and then the percentage was 10%. If we only had 10 people, maybe 20% of the people would do it. And I can't explain to you why, but that's just the way to think about this stuff. You don't really have to know it other than if you had a question like this. I will not give you a question like this, but there might be some on the homework, okay? I won't give you a question like this on the exam. So that's percent ionization. And once again, lower initial concentration gives a higher. So what you could do, what would be a fun problem to practice doing on your own, is find the pH of all three of these solutions and find the percent ionization of all these three solutions. So if you want to do something that would be good work and help you immensely for this section, do that. Am I going to test you on? I mean, am I going to like collect it? No, I am not. Okay. So the last thing from chapter 15 is finding the pH of mixed acid solutions, finding the pH of bases, and then finding the pH of salts. Okay. Mixed acid solutions, generally, you can ignore the contribution of the weaker acid unless there's two acids with very similar Kas, in which case it would suck and there's a way to do it, but I will not test you on that, okay? What you have to be able to do is if I give you, so let's say we were talking about a 0.1 molar HCl solution and a 0.1 molar, what is that? That's called formic acid solution. Now we would see that we have a strong acid that is going to generate protons. We have a weak acid that's going to generate protons, and then we have water that's going to generate protons. We automatically know that water is going to be negligible compared to the actual acid that's in there, right? So we can eliminate that one. Now this is a pretty strong weak acid. So compared to other weak acids, it's pretty strong, but when you compare it to a strong acid, it's what its name is, really weak, right? So that's like saying you're the best basketball player at this school, but guess what? When you go into the NBA, you're not that good. Anybody see the bad news about our former SSU student? He got hurt yesterday. Still had a great season though. But he got knocked out in the game. It was bad. Did you see that? It was bad. He broke his wrist. He got like carted off. It was gnarly. So when we're trying to find the pH of a mixed acid, we're gonna ignore all the weaker acids and only look at the pH or the contribution of the strongest acid. Okay, once again, it's like if we compare the amount of money that Elon Musk makes I make and my son makes, does my salary compete with his? No, of course not. I'm a teacher. My kid's salary competes with my salary, and he doesn't make any money. So the kid would be like the water, pretty much no contribution. Mine would be minuscule, and then the strong would be the one that we deal with. Okay. So if we ignore the contributions of the weak acid, the complete ionization of the strong acids provides more than enough H3O plus to shift the weak acid equilibrium to the left so far that the weak acids added H3O plus is negligible. When you have a mixture of weak acids, you generally only need to consider the stronger of those weak acids for that same reason. Okay, so let's go ahead and find the pH of a mixture of two weak acids. Okay, so what we see here is we have a 0.150 molar HF, 0.100 molar HClO, so hydrofluoric acid, perchloric acid, and it's showing three different acid generations. Tell me one of these that can be ignored, please, Dustin. So HF has a Ka of 10 to the negative 4. Perchloric acid has a Ka of 10 to the negative 8. And water has a Kw of 10 to the negative 14. Which one can we definitely? We're going to ignore water. Okay. Now between hydrofluoric acid and perchloric acid. So I had some people in office hours yesterday. Did anybody in this class know that I have office hours a couple times a week? I just wanted to throw that out there. Okay. You're allowed to come and talk to me. But someone told me that they were having a hard time because they were always looking at the front number in the Kas. The front number is pretty much meaningless. What's the important number in Kas? It's the times 10 to the negative, okay? And in Kas, a smaller number for negative, less debt is more money than more debt, right? If you owe negative $1 or you owe negative $10 or negative $9, which situation would you rather be in? Huh? You'd rather only owe $1, right? So the negative 4 is bigger than the negative 8. So we're once again going to eliminate that one. So now to solve for this mixture of weak acids, all we're going to do is solve for the H plus concentration that the HF generates, and assume that the small amount that the perchloric acid adds is pretty much meaningless. Okay, so once again, this is like number 2 on the quiz today. You're gonna write out your equilibrium. Water is ignored, so we put the acid combined and the H plus and the F minus. We start off with 0.150, 0 and 0. We add to the 0 side plus x's. We subtract x from that side. Do we think we can make x negligible? Yes, no? I would make it negligible, and I do every time. Okay? So notice how x is small assumption. So we make that x as small assumption. So we get x squared over 0.150. This is something that I wanted to show you. A lot of times you just take the Ka times the initial concentration. So when we bring this initial concentration that's on the bottom over to the other side, we end up multiplying them. And since you had x squared, you take the square root of that. And that's kind of a shortcut that is going to work a lot. It's not always going to work, but if you're going to be like, I either know the shortcut or nothing, I'd rather you know the shortcut. I'd rather you know how to do it solidly, because then you can apply it to everything. And then when we get to the later sections, knowing the fundamentals will make your life easier. But if you just learn shortcuts all the time, it's better than learning nothing. Okay? So we solved that this is going to have an x value of 7.2 times 10 to the negative 3. We divide that by the initial concentration for the 5% check. Was this approximation valid, Kayla? Just barely, right? So we could say that this, if we were just finding the percent ionization of this acid, it would be 4.8% ionization. It also tells us that it's less than the 5% check. So our assumption or our approximation is valid, though barely so. And what is the pH of this solution? How do we find that? How much? Use your calculator. Punch it in. Anybody got it? So we should be typing in our calculator negative log of 7.2 times 10 to the negative 3. How much? So negative log of 7.2 times 10 to the negative 3 is 2.14. Did everybody else get that? If you did not get this, you're typing into your calculator wrong. Do you just be like, oh crap, I just really suck at calculators. I'm just going to fail this class the rest of the time? Or do you think you should learn how to use your calculator? What do you think's the better thing to do? Figure it out, right? Every calculator is different. I just borrowed a calculator from the chemistry department office, and I couldn't even figure out how to do log for like 5 minutes before I finally figured it out. So not all calculators are created equal. So learn to use a calculator that you're going to use when it comes to tests and stuff, right? Practice with what you're going to use, right? You don't like, if you're in a sport, you don't wear crappy pairs of shoe all the time and then wear your brand new shoes for the game because you're going to get blisters, right? And then you're like, oh, well, the reason that I didn't do good was I don't care about the reason. Use the shoes that don't give you blisters and do good. Use the calculator that you know how to use and do it, okay? So if you don't know how to do this, guess what? You're going to have a hard time on the quiz today. But good news, are you allowed to use your cell phone calculator on the quiz today? I don't give a crap. You can talk to other people, okay? But learn to use the thing that you're going to use, okay? So 2.14, is that what we had? Good job, Bryce. So conceptual check. Let's not do this conceptual check. That's a dumb one. So with strong bases, calculating the pH of a strong base. For ionic bases, practically all units are dissociated. When we say practically, we're going to assume it's 100%, okay? So with the strong bases, these are our strong bases. Is this an important list to have? What do you think, Bailey? Why? Because if it's not one of these, it's a weak base, and we would then know we have to look up a Kb value, okay? So for strong bases, the OH minus equals the molarity. Unless we're looking at one of these bases, then what is the OH minus going to be equal to? Abby? So anytime we have a strong base, the OH minus concentration will equal the molarity. But that's actually really only for these three. For these three on this side, how is that going to differ? If we have a 1 molar SrOH2 solution, what's the actual OH minus concentration? No, Jack. Why is it 2? Because 1 mole of this SrOH2, so this is like gloves versus hats, right? If we have 100 people and they all take off their hat, we have 100 hats. If we have 100 people and we all take off our gloves, how many gloves do we have? 2 times 100, so it's 2 times the amount. So in this case, we would have a 2 molar OH minus concentration. And if I asked you to find the pH of this solution, you would use the OH minus of 2.0 molar, and then you would either find the H plus and do negative log of H plus, or you could do the negative log of the OH minus, which gives us what, Meredith? The negative log of OH minus gives us what? Starts with a P and ends with a OH. POH, very good. And from the POH, we can find the pH, how, Riley? 14 minus the POH equals the pH, okay? So pH plus POH equals 14. There's that little thing. Let me see if I have it right here. Remember, is it not here? So it's on the other one. It's that little chart that has all the different things where you go from H plus to OH minus. to POH to pH, and they're all related. Sometimes you can't go straight across, so you have to do a two-stepper, either up, right, or right, up, whichever way you want to go. So for finding the pH of a strong base, you just know how much the OH minus concentration is. The book likes to do it where they take the OH minus concentration, divide it by 1 times 10 to the negative 14 to get the H3O plus, and then find the pH of it. Like I said, I would do negative log of 0.225. Who can tell me what negative log of 0.225 is? 0.64. And then pH plus POH equals 14. So 14 minus, and this is the POH, right? 14 minus POH. So 14 minus 0.64 would give us 13.36. That's pretty close to the 13.352. Okay. So it'll give you pretty much the same answer. All right. Any questions on this? So that's strong bases. With weak bases, so we're not going to have time to do this whole problem. I'm just going to show you it today. You can work on it on your own. For a weak base, a base reacts with water. Water donates a proton, so you get BH plus and OH minus. So the KB expression is BH plus times OH minus over the base's initial or not initial, but equilibrium concentration. So if we have a weak base like NH3, we can still make an ice table for this. It's a weak electrolyte. Here's some weak bases. And here is an example of finding the pH of a weak base. Feel free to look at this. We'll do this on Monday. Though on Monday, I want to get into buffers because buffers is what we're doing in lab next week. I think. I don't remember. Let's go ahead and start this quiz. Okay? So the quiz is on Canvas. What should be the secret word that you type into the chat? I mean, yeah, you type into number 4. Huh? What? Give me a cool word that no one who's not here is not going to know. That's too long. Give me one. Nana? Nana is the secret word, okay? So write that for number 4, and you'll get credit, okay? Everybody who's here, here's so the quiz. Well, if you have, if you look in Canvas, you have to submit this on Canvas. Take those and pass it back. Take this and pass it back. You can keep these pieces of paper. This is all going to be submitted on Canvas. Take some of those. So if you go on the Canvas, you can find the actual questions. These questions are right here. Here's some of this. Here's some of this. Nada de this so special.
My two thank you.
Who else needs one? So you have 30 minutes after class to submit this. If it takes you a little longer, make sure for that number 4 you just write in whatever. Okay? If you're on Zoom, hopefully you heard what I said. If not, you better find a friend in the next 30 minutes in class to figure that out. Here's the quiz. In-class quiz. Get off of this. So if you're not here, here is the quiz. Calculate the pH of a 0.025 molar HBr solution. Calculate the pH of a 0.18 molar HX solution. Calculate the pH of a 0.07 molar calcium hydroxide solution. Write down the secret code on the board for those in class. There it is. Okay. Sodium, sodium. And there's the problems for those of you on Zoom. Get your exam corrections back by next Friday. For exam corrections, what you need to do is correct everything you got wrong, figure it out, and you need to come talk to me, the SI, or the tutor who comes on Monday, Wednesdays, and Thursdays in the Darwin lobby from 8 to 9:15. Who doesn't have, so Anna is yours. Sophia Otran here. You. Guadalupe here is Tiana. Ariana? Sydney? Brandon Belford? Ashlyn Brown here? Fabian? Carrillo? Alondra Castro? Curtis? Whose bag is this? Kayla España? Adric Flores? Bianca? Zeus? Just in time for the quiz. Molly? Jesus? McKenna? Maria Fernandez, Ella Mack, Ida, Bailey, Fabian Martinez, Fabian here, Angie, Michelle, Bitsy Moore, Hunter Morgan, Alexandra Moreno, Natalia, Chaos, Fargo, Savannah Parker, Bacon Ramirez, Angelina, Lucia, Avery. Okay, raise your hand if you didn't get your exam yet. Yeah.
Wait, so I didn't. I just went like. I just swear it was the next block, maybe 2 blocks, and then.
Everybody over here got their exam? Everybody over here got their exam in the middle? Yeah, you need one? Oh. All right. See somebody even laugh. Yes.
I mean, I was
Sherman, why don't you say you think it's your test? Come on.
What? Oh, I was supposed to. Oh, I was on the chat.
Which we have to read because it works on campus with